Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing graph intersections. This is part one of a two-part video, and we begin here with conceptual problems. So the line y equals x plus 1 intersects the graph of y equals x squared minus 3x minus 11 at the points A and B. Find the coordinates of A and the coordinates of B. You must show all your work. So you should understand, the basic concept here to understand is that if two graphs intersect, then we have to equate them to find the point of intersection. So this is y, this is y. Y equals y because they intersect together. So therefore, the expression for y must equal the expression for y here as well. And all we have to do now is just solve and find x. So we take the x to the other side and the 1 as well. So we get x squared minus 3x minus 11 minus x minus 1 equals 0. And we collect the like terms together. So we have x squared minus 4x minus 12 equals 0. To find x, we can either factorize or use the quadratic formula. Here, this is quite simple. This is just x minus 6 times x plus 2 equals 0. So either x equals 6 or x equals negative 2. Of course, we have to find the y. So it is definitely simpler to plug here than to plug here. If you plug in either one, you will get the same answer for y. However, this is much easier to evaluate. So x plus 1, y equals x plus 1. So of course, y equals 7 and y equals negative 1. 6 plus 1 and negative 2 plus 1 as well. So we have 2 points here, 6, 7 and negative 2, negative 1. And these are the correct answers here. The line y equals x plus 1 intersects the curve y equals x squared plus x minus 3 at 2 points. Find the coordinates of the 2 points. So again, we just equate both expressions. So x squared plus x minus 3 equals x plus 1. We take the x and 1 to the other side. So x squared plus x minus 3 minus x minus 1 equals 0. So here we have x squared and then x minus x, they cancel out. So x squared minus 4 equals 0. This is a difference of 2 squares. So x plus 2 times x minus 2 equals 0. So either x equals 2 or x equals negative 2. And like I said before, it's much easier to plug here. So if we plug, we get y equals 3 because we're adding 1 basically. So negative 2 plus 1 equals negative 1. So our 2 points are going to be 2 and 3, or negative 2 and negative 1. And these are the correct answers here as well. Again, we have two graphs that intersect. So the main concept here is to understand that intersecting graphs are equal to equating the two expressions together. However, the challenging part here, or the slightly different part, is that y is not isolated. So first we need to isolate the y. So y equals negative 5x plus 8. All I did here was just take the 5x to the other side. And now negative 5x plus 8 equals this expression here, 2x squared plus 6x minus 13. Now we take everything to one side. So I'm just going to take the 5x to the other side as well as the 8. I get 2x squared plus 6x minus 13 plus 5x minus 8. We have to change the signs, remember? And all of this is equal to 0. So 2x squared plus 11x, 6 plus 5, and then minus 21 equals 0. You can again either use factorization or the quadratic formula. I will first attempt factorization. If it doesn't work, then the factors are not integers. So I will have to use the quadratic formula instead, but factorization is usually quicker. So I'm just looking for two numbers multiplied by each other. That would give me 42. And because of this minus sign here, their difference has to be positive 11. So we're looking for factors of 42. So 1 times 42, or 2 times 21, or 3 times 14. Of course, 3 times 14 would be the correct answer here because the difference between them is 11. So 14 minus 3 is equal to 11, and 14 times 3 is equal to 42. So therefore, I'm going to write two brackets. I'm going to first put 2x in both. So because it's 2x power 2, I just ignore the power 2 and I put 2x. I'm going to put plus 14 and minus 3. This is equal to 0. If there is room for simplification, I should simplify. So 2 and 14 become 1 and 7. So our two factors are x plus 7, 2x minus 3 equals 0. To get the values of x, we have to solve each one separately. So either x plus 7 equals 0. Let me just use some empty space here. So either x plus 7 equals 0 or 2x minus 3 equals 0. So either x equals negative 7 or 2x equals 3. So x equals 3 over 2. Now we can plug them into this equation here to get the y. So y is negative 5 times negative 7, which is positive 35, plus 8, y is positive 43. Here, for the second value, negative 5 times 3 over 2, this is negative 7.5, plus 8 gives us positive half. Excuse me. So our 2 points are, point P would be negative 7 and 43. And point Q would be 3 over 2 and half. Let's check these out together. So the final answers here are negative 7, 43, and 3 over 2 comma half. These are the correct final answers. So for the following question, we have y equals x minus 1 all squared and y equals half x plus 1. And they intersect at A and B, and we want the length of AB. So first we need to get point A and point B by following the same procedure again. X minus 1 squared equals half x plus 1. Of course, I need to expand the bracket, so I get x squared minus 2x plus 1 equals half x plus 1. I take the half x and the 1 to the left-hand side. So x squared minus 2x plus 1 minus half x minus 1 equals 0. And then this becomes x squared minus 2x minus half x would be minus 2.5x. And then 1 and negative 1 will just cancel out, so this is equal to 0. This is easy to factorize. You take x as a common factor, and you get x minus 2.5 equals 0. So either x is equal to 0 or x is equal to 2.5. In both cases, we have to plug them into one of the equations to get the y. So we can plug them here or here, doesn't matter. I'm just going to use this one, it looks easier. So 0 minus 1 is negative 1. Negative 1 all power 2 is positive 1. So y here is 1. And then 2.5 minus 1, this gives me 1.5. And then power 2, this gives me 2.25. So we have 2 points now. Point A, which is 0, 1. And point B, which is 2.5 and 2.25. We want the distance between them, so the distance formula is root of x2 minus x1 squared plus y2 minus y1 squared. We substitute the values, so 2.5 minus 0 squared plus 2.25 minus 1 squared this is equal to root of 6.25 plus 1 to square 1.25, which is 2.25 minus 1. So 1.25 squared. I'm going to need a calculator for this. 1.25 squared gives me 1.5625. We add up the two numbers and we get the square root. So it will give me a root of 7.8. And the final answer is 2.795, which is approximately 2.8. This is our final answer. So 2.795 is correct and 2.8 is also correct. The curve y equals x squared minus 2x plus 1 is drawn on a grid. A line is drawn on the same grid. The point of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 equals 0. Find the equation of the line in the form y equals mx plus c. So this is the same problem, but in a slightly curved manner. You're given the final equation that we obtain after subtracting the two functions, or after equating them first. So if we equate and subtract, we get this expression. And one of the functions is this expression here. So let's just call the other function, which we don't know, y equals f of x. This is supposed to be some sort of equation. And had they given us this equation, we would have equated these two together and subtracted like we did before. So let's try to do the same thing here. We have x squared minus 2x plus 1 equals this unknown function or expression, f of x. We take it to the left-hand side. So x squared minus 2x plus 1 minus f of x equals 0. Now, they told us that the actual expression looks like this. So x squared minus 7x plus 5 equals 0. So our expression should be the same as this expression here. So we can just equate the two expressions together. So x squared minus 2x plus 1 minus f of x is equal to x squared minus 7x plus 5, because they're both equal to 0, so they're both equal to each other. Now we want to isolate the f of x. So let's try to take the f of x to the other side so that it becomes positive. And let's take this entire expression and move it to the left as well. So we have x squared minus 2x plus 1, and then minus x squared plus 7x minus 5. And all of this is equal to f of x in the positive. Our target is to get an expression for f of x. So all you have to do now is just simplify. So x squared minus x squared, these cancel out. Minus 2x plus 7x gives us positive 5x. 1 minus 5 gives us minus 4. So f of x equals 5x minus 4. F of x, of course, is just like y equals something. So you can just remove f of x and put y. So y equals 5x minus 4. And luckily enough, this is the same format that they wanted, which is y equals mx plus c. So y equals 5x minus 4 is the correct answer here. The diagram shows a sketch of the graph of y equals f of x for negative 1.5 less than x less than 6. The coordinates of 5 points on the graph are shown on the diagram. F of x equals k has two solutions in the interval. Write down a possible integer value of k. So we are told here that y equals f of x cuts the curve twice, because we have two solutions here, and f of x equals k. So we can think of this as y equals k, where k is a number. The graph of this expression is a horizontal line, y equals 5, y equals 6. All of these would be horizontal lines cutting the y-axis at k. So what horizontal line would cut this curve twice? Let me draw an example of a line here. So this line here would cut the curve twice. So what possible values are there for the value of k? Remember that k is the value on the y-axis where this line cuts to the y-axis itself. So what possible values are there for k? Any value between 3 and 5.5 would work. So here they just want a possible integer value. So let's go above 3 and below 5.5, maybe 4 or 5. Either one of these would work. So you can write 4 and you can write 5. You should not be writing both, but I'm just writing them down here so that you would understand that both of them are correct. F of x equals j has no solutions in the interval negative 1.5 to 6, where j is less than a or j is greater than b. Find the value of a and b. So no solution means that the horizontal line here will not cut the curve at all. So what horizontal lines would not cut the curve? I'm going to draw two of them now. So if you see this blue line here, any line below this blue line would not cut the curve at all. So the y value of this blue line is 3. So 2 or 1 or anything below 3 would not cut the curve at all. So therefore, a should be 3. And the reason is, if j is less than 3, the line would not cut the curve at all. Similarly, if we draw a line intersecting the maximum point on the curve, excuse me, any line above this blue line will not cut the curve at all. So the maximum value is 10. So if j is greater than 10, then again, there will be no solution. So 4 or 5 would have worked, and 7 and 8 and 9 would have worked as well, but we were just required to find one number, and a is 3 and b is 10, like we said. So this seems to be okay. The graph of y equals x squared minus x plus 1 is shown on the grid. By drawing a suitable line on the grid, solve the equation x squared minus 2x minus 2 equals 0. So we want to draw a line that would lead us to this equation here. So our line is, again, y equals f of x, and it will intersect the curve so that when we solve the equations together, we get this equation here. So like we did in a previous question, we're going to say x squared minus x plus 1 equals f of x. X squared minus x plus 1 minus f of x equals 0. This is the same as their equation, which is x squared minus 2x minus 2 equals 0. So now we equate our equation with their equation. So we have x squared minus x plus 1 minus f of x equals x squared minus 2x minus 2. We can isolate the f of x, take it on the right, and take this expression here on the left. So we have x squared minus x plus 1 minus x squared plus 2x plus 2 equals f of x. Now we simplify. So x squared cancels negative x squared. Negative x plus 2x is positive x. 1 plus 2 is positive 3. So x plus 3 equals f of x. So this is the line that we want to draw. If we drew this line, where it cuts the curve would be a solution of this equation. So x plus 3 passes through 2 points. To draw the line, we need 2 points, of course. Let's use a table here. If x is 0, y is 3. If x is 1, y is 4. So therefore, 0, 3, and 1, 4 are 2 proper points to use. 0, 3, and 1, 4. We want to draw a line to see where it cuts the curve. So the line should look something like this. And it cuts the curve in 2 positions. It's not a very accurate line, but it's the best I can do on the screen, to be honest. So somewhere here. You should use a ruler, of course. So the two values are roughly negative 0.5 maybe, and something along the lines of 2.8. These are not very accurate answers, and they might be wrong because I'm not using a ruler. I don't have the privilege of using pencil and ruler here. So the solutions are somewhat close to these numbers. Let's see what the marking scheme says. So negative 0.7 to negative 0.8 and 2.7 to 2.8. So at least we got one of them right, which is this one. However, my second point was a little bit to the right, should have been maybe shifted a bit to the left. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.